take a look at these two statements for a moment. We have the statement, it is not the case that Alice does not know how to juggle. And we also have the statement, Alice knows how to juggle. Now, it should jump out at you that there's a relationship between these two statements. We can see it even better if we symbolize them, because these statements both use the same simple statement, and that is, Alice knows how to juggle. We'll call that statement P. That simple statement is just our second statement. The first statement is a little bit trickier to symbolize, because we have this, it is not the case that. That means negate everything that's coming up. What are we negating? Alice does not know how to juggle. Well, Alice does not know how to juggle is the negation of Alice does know how to juggle. So we're negating the negation of P. We could say that as not P. That first statement, where we're negating a negation, that's called, creatively enough, a double negative. Now, English teachers like to tell you that when we have a statement like that, it cancels out to be a positive statement. And when English teachers tell you that, it's a fib, but it's short. Well, certain formal forms of English don't allow for double negation like that. In natural languages in general, including in many forms of English, double negation carries a shade of meaning. Either a shade of meaning on a positive sentence, like, well, he didn't not skip class, or an emphatic shade of meaning on a negative statement, like, I don't have no money. Nobody hears that and thinks that you really have money. So, double negation carries shades of meaning in natural language, but it is true in logic that a double negation cancels out. And that's why I used that sort of stilted formal logic, it is not the case that phrasing in my example sentence, because it's clear there that I mean a logical double negation. So let's examine the truth tables for a statement and its double negation. So here we just have one simple statement, P. To negate that, I'll look at the column P and just take the opposite. When P is true, its negation is false. When P is false, its negation is true. But then for the double negation, well, I want to take my negation and negate it again. So the opposite of false is true. The opposite of true is false. What I get when I do that is exactly the same column of truth values that I started with. We notice that the statements P and not P have the same truth value in every row of the truth table. When we have statements like that have the same truth value in every row of the truth table, we call those equivalent. More formally, two compound statements are equivalent if they have the same truth value, no matter what truth values the simple statements have. We can recognize this by seeing that every row in a truth table is exactly the same. We use this symbol that looks like an equals sign, but with 3 lines in it instead of 2, to indicate equivalent statements. Why? Because writing is equivalent to takes a long time. What we just saw in the truth table that we made is that not P is equivalent to the simple statement P. So we would write not P. We read this symbol as is equivalent to P. Like an equals sign, that equivalent symbol can be used in either order. So we could also write P is equivalent to not P. And in a lot of ways, this equivalence is the same as the notion of being equal in algebra or being congruent in geometry. It means that they're the same from the point of view of logic. And we will be able to make use of that fact when we're trying to analyze arguments without resorting to a truth table.